Proportions and similar polygons. First, we're going to take a look at what a proportion is. We've probably seen proportions before. Proportions are simply two equal fractions that can be solved by multiplying diagonally. For example, if I have a over b equals c over d, we can multiply the diagonals to get a times d. And that is going to be equal to the other diagonal, b times c, and often that's going to be much easier to solve than the fractions themselves. So here's a couple examples we're going to try and solve for our missing variable. In this first example, when I multiply the first diagonal, 5 times 9 is 45. When I multiply the second diagonal, 4 times x is 4x. And we know when we multiply these diagonals, they're going to be equal. So I just have to solve the equation 45 equals 4x by dividing both sides by 4. When I do, as a decimal, x is equal to 11.25. Let's do one more example. Here we've got 3 over 2x minus 1 equals 6 over 3x minus 5, but it's still a proportion. We can still multiply the diagonal. 3 times, and we have to put it in parentheses, the entire 3x minus 5 is going to be equal to the other diagonal. The other diagonal is 6 times the 2x minus 1. And this is going to take a few more steps, but it's nothing we didn't cover in Algebra 1. We can distribute through parentheses to get 9x minus 15 equals 12x minus 6. And then balancing on the equal sign, we'll move all the x's to one side by subtracting 9x. To get negative 15 equals 3x minus 6. Add 6 to both sides to get negative 9 equals 3x. And finally, divide both sides by 3 to get negative 3 is equal to x. So with proportions, two equal fractions, we can solve them by just multiplying diagonally. What does that have to do with geometry? Well, that has to do with geometry when we're talking about similar figures or similar shapes. Similar shapes, quite simply, are the same exact shape, but they're different sizes. When they're different sizes, it turns out that the angles are congruent, but the sides are proportional. So for example, if I've got two triangles, these two triangles are different sizes, but they're the same shape. They've got the same angles. They're so similar. Their sides are proportional. This chapter seems to have a romance theme on its humorous side. Another thing about triangles, though, is triangles that have two congruent angles are automatically similar. All you need is two congruent angles, and you can say, these triangles are similar. So for example, I've got these two triangles here. We've already got marked that angle A here is 112 degrees. Angle E is marked congruent, so we know it's also 112 degrees. In the center, we see vertical angles. 24 is a vertical angle with the one across from it, so it has to also be congruent. It's also 24 degrees. This means that we've got two angles that are congruent between the two triangles. The triangles then are similar. We would say triangle A, B, C is similar, that's what the little squiggly means, to the other triangle. Now the order matters a whole lot here. Angle A was 112 degrees. We started with the 112 degree angle, so on our similar triangle, we also have to start with the 112 degree angle, so that would be angle E. B was the second angle. B was the one we did not know, so I have to list second the angle we don't know, which would be angle D. Finally, C was the vertical angle in the middle, so it's congruent to, well, the other C on the other side. So when we're going to set up a proportion to figure out the missing angle, x, we need to know what side x corresponds with. X on the big triangle is on the same side as which side on the other triangle? Notice x is between the 112 and the 24. it's going to correspond with the one that's between the 1, 12, and 24 on the other triangle. So x and 16 correspond with each other, so we use them to make our first fraction. That is going to be equal to, we need another set of sides that correspond with each other. On the small triangle, we've got a 32. 32 is between D and E. Between the D and E. Notice those are the first two letters in our triangle. Those have to correspond with the first two letters A and B. So A and B, AB is the 56. Notice the 98, we don't even really use it. It's kind of there to trick us. Don't use the 98 because we don't know what it corresponds with. With the first fraction, we put the big triangle on top and the small triangle on the bottom. We're going to do the exact same thing with the second fraction. The big triangle's 56, the small one's 32, and now we have a proportion set up that we can solve to find our x. We multiply diagonally. X times 32 is 32x. The other diagonal is 16 times 56. I'm going to use a calculator on that one because it's going to be big, 896. But I know I can get the x alone by dividing both sides by 32. And again, a calculator is going to help a whole lot. 896 divided by 32 is 28. So the missing value is 28, and we got that because we knew the sides were similar. Proportions and similar polygons. Multiplying the diagonals to solve the proportion. Similar polygons, we find those corresponding sides and set up that proportion. Take a look on the homework assignment and let your instructor know if you have any questions.